Okay, we're going to look at formula of a hydrate. So we're going to consider MgSO4xH2O. How do you find X and then the formula of the hydrate? Look at our setup here. We've got a crucible with a solid in it on a burner. The crucible and the solid together have a mass of 15.9 grams. The crucible has a mass of 11 grams, which therefore means that there's 4.90 grams of magnesium sulfate XH2O. So we don't know what X is. Alright, so after it's been heated, the mass of the crucible and the leftover solid is 13.44 grams. Subtract off the 11 grams from the crucible again. That's going to leave you 2.44 grams of what we're going to call anhydrous magnesium sulfate. So anhydrous just means without water. So all the water's been removed thanks to the heating. Okay, of the original 4.9 grams of magnesium sulfate something hydrate, right, 2.44 grams of that is magnesium sulfate. Okay, therefore that means the difference in the two masses must actually be all water. So do the subtraction here. 2.46 grams of the original hydrated compound is actually water, and this water has been lost due to heating. So that was the sizzling sound you'd hear in the actual experiment. I'm going to convert both of these masses to moles now. So the mass of magnesium sulfate, 2.44 grams, I'm going to turn that into moles. So molar mass of magnesium sulfate, I'll calculate that for you in a second. Alright, this would yield moles of magnesium sulfate. I can do it again. So 2.46 grams of water multiplied by 1 mole of water over the mass of water, so 18.02 grams. Alright, this is going to yield moles of water. Alright, so we'll bring up a calculator here and we'll punch both of these in. Alright, so first we'll get the molar mass of magnesium sulfate. Alright, so we'll take 2.44 divided by the magnesium sulfate, 0.02 moles. Alright, and then we'll run the same type of calculation for water, so 2.46 divided by the molar mass of water is 0.14. So write this value in, 0.14. So now we need to know the ratio of water to magnesium sulfate. So how many moles of water are present for every 1 mole of magnesium sulfate? Alright, so this can be expressed as a ratio. The most common way to do this is going to be to divide. You're going to divide moles of water by moles of your anhydrous salt. Right, which is why you needed to get the masses of both of them. You need to go to moles. Right, so that you can complete this operation. This is going to solve for that X value. It's going to tell you X actually represents moles of water in the compound. So in our case, 0.14 divided by 0.02 is 7. X equals 7. The formula of the compound is MgSO4 7H2O, which is also known as magnesium sulfate heptahydrate.